let's see for the signal that we have drawn.
Okay.
So we were taking a signal like this, which is 0 from minus infinity to 0, and then it goes up, let's say by unity height 1,
Okay.
and this is time domain. You were mentioning some name for this.
It is called a unit step.
Okay.
That is what I've learnt. And u of t is what they used to call it.
Actually, nice name.
Yes.
It's actually just stepping at 0 with a height of unit.
With a height of unit. Correct.
So,
Correct.
so it's u of t, huh?
U of t.
U of t. Okay. So if I have to find out Laplace transform of this, so what we are saying is we want to find Laplace transform of u of t.
Yes.
So
you have to take the function.
yes, I have to integrate from 0 minus to
Infinity.
infinite.
So the function multiplied by e power minus st dt, no?
Yes.
Okay.
So f of t here is u of t,
U of t, yes.
e power minus st dt. And what we are saying is u of t is 1 from 0.
Correct.
So then it becomes integral from 0 minus to infinite e raised to minus st
dt.
dt.
Okay. Oh, this is easy.
That's easy.
This is easy. Okay.
So this will become e power minus st by minus s
By minus s. Correct.
limit 0 to
Correct.
infinity.
Correct.
What will be this?
Okay.
E power infinite
Yes.
is
Yes. So e power minus infinity is
correct,
0.
correct,
Right?
correct.
So that is 0.
correct. So that will be 0.
Yes.
Then e power 0 will be
1.
1. So I have minus
Minus of
Minus.
Correct. Correct. 1 by s.
1 by s,
Yes.
which is
1 by
1 by s.
Perfect. Oh, okay.
So what we are saying is if we have a time domain signal u of t, when you transform into Laplace domain,
Laplace domain,
then this becomes
1 by s.
1 by s.
So if I actually pick up a textbook
Yeah,
and look at the tables,
yeah,
if I look for u of t, I will see Laplace transform 1 by s.
yes.
Okay.
And this height 1, it could be something else also. Let's say it's
Correct.
10.
Okay.
Then it just becomes
10 times, no?
10 times.
Correct. Because instead of u of t, I can just easily say 10 times u of
Yes,
t.
yes.
Right? That new function.
Yes.
Okay. Okay. And then everything I would go, it will be 10. 10 will just go outside the integral.
Correct.
So it will just be 10 by s or whatever that is.
Exactly.
Okay.
Exactly.
Perfect.
So that way, this is a very useful signal also. Step input,
Correct.
like the switch you are closing.
Correct.
Even let's say there was an output coming, but you want to pass that only from 0 onwards, we can multiply that with a step.
That is true.
Nice. So what else we do? Sometimes I see the same step signal, but it's not going up at 0. Huh?
Okay.
But then, I mean, this is 0 for some more time, and then suddenly that guy is coming up.
Okay.
Have you seen this kind of thing?
Yes, yes. So it's like throwing the switch. You wait for some time and then throw the switch. Not
Yeah.
at equal to 0.
Yes.
Right? Yes, yes, of course.
So basically, it is shifted in time
In time.
by some amount.
Right.
Let's say time t equal to a
A. Okay.
is going up.
Okay.
Let's keep the same height and so on. So can I use u of t to represent this, or?
No, of course not. It's a different function. The
Correct.
time domain function looks
Correct.
different.
I cannot use
right?
that directly.
It is also not scaled because the value is still 1 once
Yes.
it turns on.
Yes.
Right?
Yes.
Okay.
It's actually u of t in some other form. It's just shifted by.
It is just shifted, right? Oh, so that means that t variable. I cannot change something outside u of t, but the t variable looks different.
Correct.
No,
correct.
What was happening at t equal to 0 is now happening at a.
Okay.
Right.
So what you're saying is u of t when we wrote when t is equal to 0,
it is stepping.
It is stepping.
Correct.
Now this function, if this can become 0 at a,
correct,
then we are done.
Then we are done.
How to do that? T
minus a. T minus a will work, no?
Okay. So let's do that.
Correct.
So what you're saying is I can represent it as u of t minus a.
Yes. Because the way I'm looking, if you can draw, can you draw u of t on the left or at the bottom?
Yeah.
So I think that will help compare. I think I see.
Correct.
Yeah. Because this new function, no, the value at t equal to 0 is the value of the original function at minus a.
Exactly.
Right?
Exactly.
So that's why this is u of t minus a. I can see why it is. It works. Right? At t equal to a, it is the step here.
Yes.
U of 0, and here it is u of 0 again.
Yes.
Correct.
So I think that's quite logical.
That's quite logical.
Now the question is, if I have this,
Oh,
how do I represent in
the Laplace domain?
Laplace domain?
Oh, okay. Let's do the integral.
Let's try. So what we want is this f of s for this signal. Again 0 minus 2 infinity u of t minus a, that is our f of t.
That is our f of t.
E power minus st.
Correct.
dt.
Okay. So quick question. I think when we said f of t has capital F of s, right? So when we make a change to the time domain signal, we normally expect a change in the Laplace transform also.
Yeah.
Right?
Yeah.
We should not expect to get, so our f of s should look similar to what we got 1 over f, but slightly different.
Yeah.
Isn't it?
Correct.
Okay.
Correct.
Okay.
It should be a modified form
of what we got
1 by
earlier.
s. That's what you are saying.
That's what we hope.
Let's expect something like that. So what we are saying is the signal will become 1 from time t equal to 0 on. Time t equal to a onwards, not 0 onwards.
Yes.
So if we can capture that, then we are done.
Correct. But now the limits of the integral will change, no? It doesn't. You don't have to start from 0 minus.
Exactly.
Okay. We can just start from a minus.
From a to infinity.
Yes.
E power minus st dt.
Yes.
Because it's 1 from then onwards.
Correct.
Okay.
So maybe we'll just call it a minus to show that it is, the step is happening there.
Yes.
Right?
Yes. Okay. Yes. So now again it's easy. Minus st by minus s.
Correct.
Limit
a minus
to infinity.
Okay.
Like you said, e power minus infinity, that will go close to 0. So I mean 0 minus. Then we have a minus.
Correct.
As the, so that is minus a s.
Correct. By s.
So there is 1 minus extra here.
Correct. That's right.
Okay. So this will become e power minus as by
s.
Yes.
Okay.
Correct. Oh. So that means I have almost the same expression.
Correct.
I mean earlier this was just 1 by s.
Yes.
Now that is multiplied by e power minus as.
E power minus as. Correct.
And a is the amount for which we have shifted in time.
Correct.
So that means f of s multiplied by e power minus as.
Yes.
That's what you were saying.
That's what I was saying. It should look similar to, you should have that 1 over s, but something else should happen, right? Okay. Correct. Okay.
Nice.
So just some small shifting,
Hmm.
you can still see 1 over s, but there is some e power minus as.
Yes, yes.
term.
So what you're saying is it's e power minus as multiplied by this 1 by s.
Correct.
Yeah.
That's right.
Yeah.
Okay. So I wonder if something like this happens for other functions also which are delayed. We should try that out later.
It should
Should
be.
remember this
Correct.
when we try this.
Correct.
We should try to find out if there is a pattern.
Exactly. So basically this
Correct.
gives that
Gives the time shift. I somehow feel
Yes.
because you shifted by a, no?
yeah.
This term only has the time shift.
Correct.
So I wonder if other functions also will come out like
Yes,
this.
yes. That's a nice observation. I think
Yes.
we will see this later.
Yes.
So shall we try some more examples?
Sure.
Because we have seen some, what's the f of s of some of the f of t's.
Correct.
Let's take some real f of t and see.
Some simple
Of
examples,
course,
right?
of
Okay.
course.
Sure.
So let's take f of t. What we know is the step signal. So let's
Correct.
modify that a little bit.
Sure.
So I have an example 2 of u of t minus 3.
Okay. So this is a unit step, not a
Yeah.
unit step, it's a step
Yeah.
that goes from 0 volts to 2 volts
Yeah.
at t equal to 3 seconds.
So shall I draw?
Please draw it. Yeah.
So what you're saying is at 0 is not going up.
It's not going up.
It will go up around at 3.
At 3. Correct.
Okay. So this is 0 till here.
And then it will go up to 2 volts, no?
Not 1.
Not 1. Because it's 2 u of t minus 3.
Yes.
Okay.
So this is.
Okay.
So this is the signal. Okay, got it. 2 u of t minus 3. Okay. This we may be able to write it directly also from the experience.
Correct.
But we will go step by step.
We'll go step by step. Yes.
So we want f of s, which is the Laplace transform of f of t. We need to integrate from minus 0 to infinity 2 of u of t minus 3. Then we have to multiply with
by e power
minus
minus
st.
And dt. Integrate.
dt.
Okay, over time. Yes.
Okay. So 2 anyway we can take outside.
We can take out. And also it looks like below 3,
It
the
is
value
0.
is 0.
Yeah.
So we can just integrate from 3 to
So we can change the limit. So
3
you used to say 3 minus.
3
also.
minus. Or now we can just say 3. I think we can.
We are familiar.
Yeah, we are familiar now. We understand.
So
We'll
3
just say
to infinite e power minus st dt.
Yes.
Okay, so that is 2
So
e power minus st by minus s.
Yes.
So minus I will keep here.
Yes.
Limit 3 to infinite.
Yes.
So minus 2 e power minus st
T equal to infinity, it is 0.
So that goes to 0.
Yes.
Correct.
Minus
Then minus
e power minus 3s.
minus 3s because t is 3 now.
Correct. T is 3 now by s.
By s.
Correct.
So this is just e power minus 3s by s.
Correct. Times 2.
Also this 2 is common. 2
That
I
2 is
missed. 2 I missed. So I'll write the 2 here also.
Correct. Okay. Yes.
It's
that's
you thought it's common. Yeah.
Yes.
Yeah. Okay. So
And then there will be a 2 also here.
yeah,
So 2
I'll write it in color.
in color just to make sure that they
Yeah.
know. Correct.
So actually we can get this from previous transforms that we know,
That is true.
because for u of t we know it is 1 by s.
Correct.
Sorry.
And we also did it for u of t minus a,
Correct.
which was e power minus as by s.
Yes.
Right?
Yeah. So if you are shifting in time,
Yes.
then it was e power
Minus as.
minus as
Yes.
by s.
By s. Correct. And then you multiply
In
by
addition,
2.
u of t is not 1, 2
Yes.
here. So it's 2.
Yes. So some of these
Exactly.
transforms properties we need to remember
Yeah.
and use them.
Yeah. Or if for some of the basic u of t's, if we can, if we have a list of transforms, then life is very easy.
That is true. That is true. I wonder, we have taken u of t, right? I wonder if that delaying time, e power minus as, does it work if you also advance? So if instead of u t minus a, I had u of t plus a. I'm curious what that will look like. We should do that at some point of time.
We will check.
We should do that.
We will check. So what you're saying is u of t is starting before
0.
So far we are seeing from 0 minus.
0 minus.
We will discuss this
We
later.
will discuss that separately.
Okay. So what shall we do next? U of t, I think we are somewhat comfortable with.
So u of t. So last term we looked at steps turning on switches with RC networks. Then we also did sinusoids. But maybe we should do something simpler before we go to sinusoids. So one of the things, I remember, if you take a current source and connect it to a capacitor,
it will charge like a
straight line. So maybe we need to see what will happen.
Is there any name for that?
I think that's called a ramp.
Ramp. Okay. RAMP.
Yes, RAMP.
So that's sorry. So what you're saying is from time t equal to 0, this guy will go like this.
Yes. Yes.
Oh. How will I write that in some f of t?
Well, let's see. Let's assume simple one, right? So, well, it will be some constant times t. All right. So, I think that is. Let's just do f of t equal to t, no?
F of t equal to t.
Equal to t. Correct. You can also do f of t equals to 2t, 3t, and so on. It will give me different slopes, no? Different slopes. But let's try the simplest one.
Now, it is starting at 0.
At 0, correct.
Can we somehow capture that using our u of t also?
Oh, u of t also. Okay.
In the sense, suppose if I multiply with the...
So then, okay, below 0, it is 0, right? Then it should be t times u of t, no? Because otherwise, then I understand what you are saying.
Yeah.
If it will extend out into the third quadrant, we don't want that.
Correct.
Understood.
So far, we wanted to restrict to the positive side a lot.
The positive time only. Understood.
So t u of t. So what we have done is we have t, and then u of t is just a step with unit height.
Correct.
So anyway, it doesn't harm anything in the positive side.
Correct.
Negative side, it just makes it 0.
Correct.
Okay. So this is the f of t. So we want the f of s for this. 0 minus to infinity t u of t e power minus st dt. Okay.
I think u of t is just 1, no?
Yeah.
0 to
so that we can make it 1. So it is t e power minus st dt.
Yes.
This is somewhat familiar.
Okay. So this is slightly more last. I think just when you had 1, it was easy, no, to integrate a constant. We just had to integrate minus s.
Yeah. So
we need to use some property or some integration, something, no?
Yeah. I sent something t e power minus st. Can I get this from some other expression? some other operation.
Okay. So if I take the derivative, no,
Ah.
of e power something, e power, if I take d by dx of e power ax,
Okay.
it will give me a e power ax.
Okay. So
Right.
what you're saying is d by. So in this case.
In this case, I want t, right?
Ah.
So I have to take the derivative with respect to s.
So d by ds.
D by ds.
Of e power minus st.
Minus st. Correct.
Okay. So this will be.
And do I also need? I think I need a negative sign also because it's e power
Or
minus
first I
st.
will write this.
First you write this.
You are too
then
fast.
We'll see what happens.
So, so I have minus t e power minus st.
Okay. Got it.
So this is what you are saying.
Yes.
Here there is no minus symbol.
There is no minus symbol.
So, okay. So that means I will just multiply with minus in both sides.
Correct.
Okay.
Correct. That will work. Oh, this is a nice property. It's interesting you noticed it. Okay.
That's what I felt some load. So that means I can place this here.
Yes.
Correct?
Yes.
Okay. Let's try that. Will it make life easier or complicated? So 0 minus 2 infinity minus d by e power minus st dt.
Okay. Now I see it is going to make your life easier. A lot.
If I know something, I guess.
Yes. I think I remember a mathematical property. So if you are taking, there is some function of two variables. If you are taking the derivative with respect to one variable and also integrating it with respect to the other variable, you can actually interchange the integration and differentiation.
So I can integrate first and then differentiate, or vice versa.
So I think that property will be very useful here.
Okay, so then let's rearrange like you said.
Yes.
So minus d by ds.
Minus d by ds can be brought out. Okay, I see.
Okay, 0 minus 2 infinity e power minus st dt.
Oh, this is a lot easier. We already know what this is, no?
Oh.
This is 1 over s. This is just the Laplace transform of u of t.
Yeah, that we know already.
Yes.
So what you're saying is this is minus d by ds of 1 by s?
1 by s, correct.
So easy.
So easy, yeah.
Because this this part we know already.
Correct.
Which is this.
Correct.
Okay. Cool. So this I just have to differentiate once.
Yes.
So 1 by s differentiate that will be minus 1 by s square.
Yeah, and then you already have another negative sign there.
Oh,
this will
so
just be
it
1
is
by
just
s
1 by s square.
Yes.
Cool.
Nice. This is very easy. I think the fact that you noticed, first that it looks similar to the derivative, that kind of
if I had used maybe when you have two things, you will use something else, no?
Correct.
Integration by parts or something.
Correct.
That's also possible.
That's also possible. What we should do is maybe they can do it as students can do it as a homework.
They may be familiar with that. Okay.
We can just ask them to do a homework by taking derivative in parts.
Good.
Yes.
Should we try? See, so far we have done unit step, ramp, nice. What else? Something exponential.
Exponential? Okay.
Let's see.
Let's try it out. Okay, I see. So you're going from ramp directly to exponential.
Yeah.
Okay.
Anyway, it's going up. Let's go it very, with a higher slope.
Sure.
So let's say I have f of t equal to e power at.
Okay. A is some constant, right?
Yeah.
Okay.
So with respect to time, it will
increase. So A is positive.
Yeah, A is positive.
Okay. Actually, it doesn't matter. No, A can also be negative. I guess we'll find out.
Yeah. We would like to go in the positive.
We'd like to go in the positive direction.
Yeah.
Okay.
So we want the f of s, which is 0 minus 2 infinity e power at multiplied by e power minus st dt. We will do some rearrangement.
Oh, okay. This is easy. So it will
So
just
I can, because
be e power a minus s times t. No?
yeah, so e power,
Uh,
I can say
s minus
s
a.
minus a
Correct, correct. Yes.
dt.
Yes.
Okay. So this will be 1 by s minus
S minus a. Correct. And
There is a minus symbol also, no?
yes, correct. There is a minus symbol.
Then apply the limit.
Apply the limit. And of no, you'll also have e power minus s minus a times t.
Correct.
And then you apply the limit.
Yeah.
Yes.
Anyway, 1 by s minus a I can take outside, no?
Yes, correct. We are applying the limits on t.
Yeah.
Okay.
So e power,
Minus infinity will become 0.
yeah. So that is 0.
0
Minus
t equal to 0.
1 by,
We'll make it 1.
yeah.
Oh.
Oh, so this is just 1
1
by
s minus a.
s minus a. What has happened? Oh. So e power at is 1 by,
1 by s minus a.
Mhm.
Okay.
So for step it was 1 by s.
Correct.
Correct?
Correct.
Mhm.
Okay.
So such a exponential function has become something just minus a.
Just some minus a. Correct. Correct.
Oh.
So it looks like there is some kind of nonlinear mapping or something
Correct,
like that. No,
correct,
it is
correct.
not just a straightforward mapping.
Yeah, it's not something that we can easily visualize.
Easily visualize. Correct.
Because you are transforming through this integral operation.
Correct. Correct.
Okay. So now we have seen Laplace transform of some of these.
Correct. And I think now students can do many other functions.
Correct.
No? They can do t squared.
Correct.
All kinds of things.
Maybe they should pick up some signals that's of interest to them and then find.
Correct. Correct.
Okay. So when we were talking about logarithm, we were saying that we will go to logarithm, do our operation, and then come back.
Correct. The anti-log.
Some inverse operation.
Correct.
So there should be some equation for that also. I mean, if this is an integral operation, that also could be another.
That is true. We need that as well.
Correct.
Okay, so we need to learn that next.
I think at least we should know.
We should know
what process will bring it back.
Okay, we should. We should.
So I was looking at again the equations. So what it says is, if you want f of t, what we should do is take. So far we were using the symbol Laplace.
Correct.
Now it is inverse Laplace, right, of f of s. Now the operation is, we do one similar integration, but not from time, because you have transformed it into S domain.
Correct. Correct.
So this will be some points in the S domain.
Correct.
Correct, no?
Correct.
So what it says is a real number c minus j infinity.
Okay.
To c plus c.
Okay.
J infinity.
Okay. So you said the S was in a complex domain, no?
Yeah.
Sigma plus j omega.
Correct.
So you are choosing some particular sigma.
Yeah.
And then going omega from minus infinity to infinity.
Correct.
That is what it seems.
So this will be a line integral.
It will be a line integral. Okay, got it. Understood. So in the complex plane, it will just be a straight line parallel to the y-axis.
Exactly.
Okay. Okay, understood.
F of s we already have.
Correct. Now this should be ds, I guess, right?
Yeah.
But there is something else. Okay.
Yeah.
The
So
inverse function.
e power st.
Okay.
You were saying ds.
ds, correct. Oh, so you have to multiply by, if I thought it was just going to be simple f of s ds.
Not that easy.
Not that easy.
Because when you came back, I mean, you reached here with some
course,
process.
Of course.
Cannot go back that easily.
That easily. Okay.
And then there is also some factor here, 1 by 2 pi j.
Okay.
C is of course a real constant.
Okay.
So what it says is, if you do this, you can get back.
You can get back that. Makes sense.
I don't want to break our head on this, because we have come here, let's say u of t, you have processed and then reached 1 by s. So if I do 1 by s, of course I will get u of t.
Correct.
So if we know the transform pairs, then you don't have to integrate all the time.
That is true.
We will just use the transform pairs and then do whatever algebra we want to do.
That is true. No,
that's what we want.
Correct. And then if you ever want to go back to the time domain,
yeah,
if I have 1 over s by itself, I know it is u of t.
Exactly.
Right? So I know those kind of relationships, if I remember,
exactly,
that is good enough for me to...
Exactly.